to understand that for variation, right? You are checking how a change in one quantity is causing a change in another what now? Quantity. Change in one quantity causing what now? A change in another quantity. I'll be as fast as possible. The first variation I want to talk about is what? Direct variation. In the case of direct variation, what happens? Increase in one quantity leads to what now? Increase in the other quantity. And then if you do decrease in one of the quantities, it will result in what now? Decrease in the other quantity. For example, if all children have the same abilities to eat, the same eating rate, really they are not paying attention, the same eating rate, and a man has 3 children, another man has 10 children. This is the amount of food. Let's say it's X. That this one will eat, and this one will eat what now? Y amount of food. Right? This X and this Y, which one will be more?
X.
3 children will eat more than 10 children.
No.
So what now? 10 children will eat more than what now? If they have the same eat, I know that there are some of you that can eat for 5 people. Do you understand? I'm saying if all the children have the same what? Eating ability. Do you understand? I know people who can eat what 3 people will eat. Yes. They will eat and they will not look like they're not eating anything. So I'm saying all of them, they have the same eating ability, right? Please take note of that. When you are comparing things to variation, you make sure that other things are what now? Are constant. That's why when we start showing, when I show you the formula, we introduce what now? K. A constant K. So as you increase this guy, this one also what? Increases. What about the man that has a child? If Z is the amount of food they will need, will it be more or less?
Less.
Do you understand? Yeah. So since this one is what now? This one is reducing. This one also what now? Reduces. I get it. In this case, we have what? A direct what? Variation. So you always ask yourself, is it directly proportional or what now? Inversely what? Proportional. In the case of variation, you're comparing different quantities. Is that right? Now, if I say A is directly proportional to B, this is how we write it. Sorry. A is directly proportional to B. This is how we're going to write it. And if I'm going to change this sign, this is sign of proportionality. If I'm changing sign of proportionality into sign of equality, I'll have A to be equal to what? KB. Right? Yeah. If I make K the subject, B will do what? Will come down. So I end up getting A over B is equal to what? K. And if I make K to come first, if I rearrange, it will be K to be equal to what? A over B. So, other factors being constant, we're going to have what now? A constant what? Ratio. Take note of that. For direct variation, you have what? Constant ratio. Constant ratio. And because this is true, if I'm giving a question that does not require my looking for the constant, I can have that what? A1 over what? B1 is equal to what? A2 over what? B2. If I want to B3 and all that, it goes on. Do you understand what I'm saying? Yeah. The ratio is what? Is constant. Are you with me? 3 important things to remember. This, let me take this out so it doesn't confuse you. This A is equal to what? A is equal to KB. This is the original one now. Yes. Then you know that the constant will be what now? The ratio. Whatever we're going to do, we'll try to what now to this thing. Are you with me? Yeah. So this is for what? For direct what? Variation. You get what I'm saying? Let's see how we can apply this in that question that we had. One of the questions that we had earlier on. A piece of land was offered. Okay, this is ratio. Let's leave this. We're going to come back to that. We had a what? Okon won a 200-meter race in what? 25 seconds. If you run at the same rate, that's constant now. The speed is constant. All other factors being constant. How long will it take him to complete what? 800-meter race. So I know that I'm talking about what now? Distance. Let's call distance x, right? And let's call time what? T. Are you with me? So I have that what? X is given to me as what? As 200 meters. And then T is given to me as what? 25 seconds. Since it's a direct question to ask, will it take him less time to cover more distance or more time to cover more distance?
More time to cover.
So what does that mean? It's a direct what now? Variation. If you increase the distance, you increase what now? The time. If you reduce the distance, you reduce what now? The time. So we have a direct what now? Direct variation. Are you with me? So, oh boy. I'm having that x is direct proportional to what? To t. Are you with me? So I'm going to end up getting what? That x is equal to what now? Kt. Are you there? So if I want to find k, which they didn't ask me to, I'll have that k is equal to what now? X over t. Alright? If we have resolved this, that k is equal to x over t, I can find k to be what? 200 divided by what now? 25. And that's going to be what? 8. Right? The original formula is what? That x is equal to what? Kt. Right? So if I put, because k doesn't change, if I put 8 in the place of k, I will end up getting that x is equal to what now? 8. So for this particular question, this is now my what now? My formula. Do you understand what I'm saying? X is equal to what? 8. Now they're asking us to find a time when x is equal to what? 800 meters. What is now the new time? Again that. We know that x is equal to what? 8t, right? So if x is 800 and I have 8t on this side, I divide this side by what? By 8. T becomes what now? 100. 100 what? Seconds. Again that. But they said we should give our answer in what now? In minutes. Okay, the question is not complete. They said we should give our answer in minutes. So convert what? Seconds to what? To minutes. How do we do that? Divide by what? By 60. If you want to convert this to minutes, it will be 100 over what now? Over 60 minutes. You can do the conversion yourself. Are you with me? This is method what now? 1. So I said because they didn't ask me to find, what is it? They didn't ask me to find because I wasn't asked to find the value of k, right? I can just use that what? X1 over what? T1 is equal to what? X2 over what now? Over T2. X1 becomes what? 200 meters. T1 becomes what? 25 seconds. X2 becomes what? 800 meters. And T2 is what we're looking for. Right? And if T2 we're looking for, I can take T2 what? Up. And bring X1 what? Down. And take T1 what now? Up. So eventually I'll get what? T2 to be equal to what? X2 T1 over what? X1. What is X2? 800. What is T1? 25. What is 200? So at the end of the day, I still get what now? 100 what? 100 seconds. And me, I will recommend that you always use what now? This. A better way to do this thing I just wrote here now, this same thing I've just written here now, a better way to do it. A better way to do this I have just done here, since the question is even an objective question. Are you with me? I won't go writing those x1, x2, killing myself, right? I'll just write the values down. There's x and there's t, right? Are you with me?
Yeah.
What's the first set of questions? We have what? 200. And then we have what? 25. Then the now we have what now? 800. And let's call it what now? X. Are you with me? It's a direct proportion, so what do? We cross what? Multiply. So I'll do this to get what? 200x to be equal to what now? 25 times what? 800. So at the end, divide this by what? 200. X is going to be equal to what now? 800. 100 times. This is very straightforward, very easy. Do you understand what I'm saying?
Yeah.
Before you know what, I'm going to take it off. Look at this one here. This one is what now? Inversely what? Proportional. Well, I'm not talking about inverse proportion. So I'm going to allow you to copy the other one before I come back to what now? To explain inverse proportion for the day. Is that okay?